All right, what is up, everybody? Back again with another MCAT question of the day. Today's question says, the inside of the membrane is blank compared to the outside. All right, so the inside of a membrane is blank compared to the outside. For this reason, the electrical force acting on the positive charges of potassium and sodium is pushing them blank. Inwards, outwards, what do we know? So the answer choices again will reflect this because it's going to say the inside of the membrane is negative or positive to the outside, and then the second choice is asking which way are the ions being pushed? Are they being pushed into the cell or out of the cell based on simply the charges, the electrical charges of those ions? So before we get started, membrane potential, that's not a new concept on these questions. That was actually one of the first questions I made, was about the sodium potassium pump. Because one of the biggest things that contributes to the membrane potential is the sodium potassium pump. Okay? The sodium potassium pump, if you watch that first video, tells you that we pump 3 sodiums out and 2 potassiums in. And what do I mean by that? What do I mean by 3 sodiums out? I mean 3 sodiums out of the cell and 2 potassiums into the cell. What this also means is that we have a net positive charge out of the cell, right? Because we have 3 sodiums out and 2 potassiums in. So you can think of that as a net one positive charge leaving the cell. Um, and so that's one of the biggest things that contributes to the membrane potential, because this basically tells us that already we have a bit of a disparity here. Because if there's a net positive charge out, the inside is going to be relatively negative compared to the outside. All right. The other thing that we also have is detailed by this picture here. All right. What I'm also going to show you is that inside of the cell also has a large amount of organic anions. So organic anions. So organic is just the fact that they're related to carbon. Anions relates to the fact that they're negative. So the inside of the cell is negative, has a lot more negatively charged organic anions, and those anions can't cross the cell membrane because they're so massive. And because of that, the negative charge actually ends up being built up on the inside of the cell. Right? So those are two main reasons why the inside of the cell is negative compared to the outside. But let me go ahead and I mean, review what we just said. So the sodium potassium pump has a net positive charge out, which also means that you have a net negative charge in, right, in the cell. The second thing is the large anions also contribute to the negative charge that builds up inside the cell. So both reasons 1 and 2, this reason 2 and then this reason 1, they imply that the inside of the cell is negative compared to the outside, right? And that's actually very true. The inside of the cell is negative to the outside, so we've actually solved the first half of our problem. But more importantly, that's also another reason why most membrane potentials are between negative 40 millivolts and negative 80 millivolts. And what I mean by that is the inside of the cell is 40 millivolts more negative than the outside, or the inside of the cell is up to 80 millivolts more negative than the outside. All right, and this is true because the cell acts as a battery. Okay, so this separation of charge allows the cell to act as a battery, and as we all know, batteries kind of function as the electromotive force in our world. And in our case, if the cell can act as a battery, there can be an electromotive force at work in the membrane as well that can help our body get a lot of signals around. The other thing that the membrane potential comes in for is excitable signals. Many of you know neurons. Neurons have action potentials, and the action potential can only arise because of this charge differential. So with that, now let's go back to our main question. Let me highlight that question in green. So the question was asking the inside of the cell is blank compared to the outside. And we know that the inside of the membrane, again, is negative compared to the outside, right? And for this reason, the electrical force acting on positive charges such as potassium and sodium is pushing them where? So remember, this is our cell right here. I've drawn it in the upper right-hand corner. The inside of the cell is negative, and then let's just say we have a bunch of sodium and potassium ions on the outside. All right, what direction do sodium and potassium electrically move? So I'm not asking about concentration. Remember, concentration gradients are an entirely different thing. I'm asking simply based on electricity. If I told you that, first of all, potassium is positive and sodium is positive, and I told you how do they move electrically, which is detailed right here at the bottom. What you would actually say is the hallmark of electricity is that positive attracts negative and that negative attracts positive. Okay, that is electricity. All right. And in this case, sodium is a positive ion, so it's attracted to negative things. Potassium is a positive ion, so it's attracted to negative things. So both sodium and potassium electrically are attracted to the inside of the cell. Okay, so again, note that there is a big difference between electrical and concentration gradient. The electrical force on potassium and sodium actually pushes them inside of the cell. All right, the electrical force pushes them inside of the cell, but that's not the only thing acting on them, because we know there's a concentration gradient. But again, in this question, it's explicitly asking the electrical force acting on the positive charges of potassium and sodium. The electrical force, so this is a bit of physics combined with biology, which is what makes it so cool. The electrical force acting on potassium and sodium is negative because the inside of the cell is negative, and therefore that force is actually pulling them into the cell, right? So in this case, A is wrong and C is wrong. And the other part is that the inside of the cell is negative compared to the outside, and therefore the best answer here is D. All right, guys, thanks for watching. Please let me know if you have any feedback, and I'll see you guys in the next video. Hey, thanks for watching the video. Really appreciate it. You want to check out any of my other videos? There's going to be one right here, another link to one of my videos right here, and another video right here. Why not? I'll put one video right over here. And last but not least, if you want to subscribe to this channel, really appreciate it, because I'm still an early YouTuber trying to get it down, but a subscription button should be right over here. So please subscribe. Cool. Thanks. See you guys in the next one. Hope you find these videos helpful.